Okey, kalau tak ada soalan, saya akan sambung ke kelas. If you don't have any question regarding assignment, I will going to slide. Where is my slide? This one. Okay. Okay. In this moment, I will touch about three subtopic. Yeah. Uh, Regarding in the air distribution, I will touch about introduction of human comfort, psychometric chart, air conditioning process in the psychometric charts. Okay, we will go in deep about this subtopic. So now we go first on the introduction for human comfort. Yeah. Human comfort expresses the level of satisfaction with a matter condition which occurred in the environment according to the perception of individual. So the most common matter are heat, thermal energy, and air purity, sound, lighting. So we will relate to the comfort not only in the temperature but also in the uh, sound or in the lighting. So sometimes lighting is a very make us you know so clear. Sometimes make us some person maybe is not comfort because uh, every person have sensitive in the lighting. Yeah, like me, for example, I very uncomfortable when the coming to the uh, uh, lighting in the in warm condition. Yeah, like warm color is like yellow. That's my very difficult to me because I cannot see clearly on that situation. Yeah, and then sometimes sound. Yeah, some very noisy, so very difficult to concentrate when we try to uh, start to work. Yeah, and finish. It maybe take a long time because we need to uh, very noisy and difficult to make uh, perform a good performance, yeah, in the noisy condition. And sometimes it's sweaty, too sweaty is difficult also to concentrate in our job, in our work. And then the air purity, maybe influence in the outdoor condition, or sometimes it's very dusty, yeah, condition, or not enough supply oxygen, anything. So heat and purity, thermal energy is amount of energy in form of heat thermal which effect on human body. Temperature, humidity, and air quality are the most known parameter related to the thermal comfort. And then sound is called sense existing due to vibration of any medium as reaching up to sense of hearing. Okay. A noise in the sound that causes discomfort. Procedure that overcome the noise is called acoustic design. The certain level of sound is called acoustic comfort. Yeah. Sometimes the condition they will serve by music condition, so make us relax, feeling in the relaxation, so we need to hear some music, maybe like classic, can make us a comfort. But some person they work with the certain type of music, maybe like rock. That one is cannot be mixed. We cannot generalize the condition to other person. So different person, different comfortable in the uh, sound. So like me, maybe I need the classic music, with the piano, or sometime with the guitar, classic guitar, and then violin. But some person they need to make like a sporty condition. So like maybe need to make the the heartbeat maybe come uh, more active, so that why they need in the uh, sound beat with the high speed, so this one only certain person can convert in that condition, so we cannot generalize this condition. Okay, now we're touching about the lighting. Lighting is the amount of heat in form of the light that is adequate for visualization. Daylight and night light, night quality are attributes for pretty and sensory. The acceptance of brightness and reflectance level for eyeball is related to visual comfort. As I mentioned before, so sometimes the person cannot comfort in the in the tone of lighting. So like me in the yellow lighting, she is not a comfort. So make me uh, in the unvisual or unclearly condition in the reading or in the work in my work, or something in the maybe I need to type, but with that lighting condition is difficult to me, and also I cannot read and that tone of lighting. Okay, this one is an example of the lighting comfort. Okay, based on the human comfort, based on the X-ray, they will give to guide us how to uh, uh, follow uh, all condition parameter to create the comfort condition in a certain zone. And let's say this condition is for seminar. Let's say this condition is for study room. Can be comfort only for the theater condition. This one is a different, depend on the application condition. The principal purpose of HVAC system is to provide condition for human thermal comfort. Human thermal comfort is a feeling of human body when tends to accept the thermal of surrounding environment with indoor air quality. So as long we can acceptance that condition, all parameter like air quality, like the temperature or humidity, we can consider that one is under human thermal comfort. So this one consider under the indoor air quality. So mean that if the air quality is avoid the all wanted particle mean the good filtration uh, operation in that area. Or maybe we don't feel like odor uh, from the maybe from the seed or leather, anything mean that humidity is suitable in that room. A thermal comfort is that condition of mind that express satisfaction with the thermal environment is under X-ray criteria. Thermal comfort becomes a worldwide attention due to its relevance with all life field. Yeah? So actually now any uh, any building room condition already completed by yeah under HVAC condition. So mean difficult to find out the or building without HVAC condition. Any building now already under HVAC control. Okay, how to find out the human comfort? Yeah, that provide uh, in a certain building. How to measure? So actually, human comfort we can measure. Yeah, human comfort effect is affected by 6 main factors. Among of them, four are called environmental factor, while the rest two called personal factor. So in the environmental factor, dry bulb temperature, relative humidity, average air velocity, main radiant temperature. And then personal factor, only one factor that provide in the human comfort, only one from the 6 given by human comfort factor. So other is from the uh, outside, from the HVAC control. But other than that, this one is not controlled by the HVAC factor. Okay, let's check. Yeah, environment factor also we can provide in the HVAC control, so we can condition it from the maybe unsafe uh, environment, let's say nearest to the industry that high emission or pollution, maybe we can create also the HVAC. We can design the HVAC condition in the building. We can design dry bulb, we can condition it by HVAC. Relative humidity. So in dry bulb temperature, they mention around 24 degrees Celsius until to 26 degrees Celsius. And relative humidity for us in tropical or for human around 30% until to 60%. Maybe in the tropical nearest to the 60% will feel comfort. Average air velocity is around 0.12 meter per second until to 0.35 meter per second. And then main radiant temperature we can calculate by formula. That is from the global temperature over 4 and plus to constant value in SI. We can use this number, and with the English we can use this number unit. So V velocity of the surround ambient, and then G is global temperature, and the TE is ambient temperature. So we can calculate. So This one is metabolism of temperature. The person mean metabolism around the dead area in the building. So then only one factor that caused by the habit, personal habit. Personal habit may be influenced by human activities. So metabolism person divide by their activity. So let's say the activity in that building is dominant by walking. So should be calculate the energy caused by walking is thermal metabolism at that value. Okay, is the habit in the that building or that area is dominant by activity sit down, like the theater room. That one is consider the activity in the sit down, and then maybe we can influence or affected by the dresses habit. Sometimes they will use their habit maybe cover all body. Like a Muslimah, they will cover all body. Maybe they choose that one every where every activities. So that will be make different situation condition to his body, so that one different where we compare to the other habit. Maybe they will choose the wearing is maybe less than that one, maybe not cover only all the body, maybe only cover in certain area. So that one also make different condition in the comfort level. So this one is considered under factor of personal factor. Okay, cloth insulation measured by standard value CLO, mean insulation. The CLO has the same dimension as the R value. So R value mean clothing thermal resistant. Because of the clothing will be act as the insulation in the thermal. So we will cover in the thermal. So sometimes they will expose to the area. So mean the CLO is insulating is lower. If the consider is the higher CLO, insulating mean is cover to protect to from the ambient condition. So we will be measure this by unit CLO. Okay, we can check the CLO later on. Okay, this one is a metabolism measure in the normal. Human activity is one metabolism is 58.2 watt or meter square, or in the British we can use 18.4 British thermal unit per hour feet square. Okay, heat balance for human body involve metabolism, heat generation by conversion chemical energy due to digesting food. This one is different person, different condition metabolism actually, but we can generalize from the condition. So we just take average condition of the person. So blood circulation, respiration, so will be influenced in the a thermal that caused by the human activities. So metabolism rate and closed insulation can be determined directly from total average heat generation and closed insulation table respectively. Metabolism rate depend on the activity, age, size and gender. Okay, let's check the table that insulation caused by uh, wearing activities. So let's say working short sleeve shirt. So maybe we will measure the insulation is lower because they are not uh, they are not cover didn't cover to all body, so maybe exposure to the environment. So the dress cannot insulate the thermal. Then trouser short sleeve shirt, trouser long sleeve shirt become increased because already long sleeve. Now you can see this yellow become increased. Same as above, plus jacket, suit jacket become increase, increase. And then this one is linear to the clothes covering, level covering. Consider a level is height to cover our body. Maybe CLO number will be increased. You can see like that. Okay. Okay, that's for the parameter that influence in the human comfort, in the certain building or area. Now we go to psychometric chart. Psychometric chart, that one is other parameter of measurement to consider the condition is comfort or not comfort. The psychometric chart shows graphically the parameter property relating to water moisture in the air. Okay, in the psychometric we can measure several conditions, humidity, and also the temperature, human comfort, and then also the enthalpy, and then what else? Air condition, air amount, quality, air amount. So how much air supplying in that room. So the psychometric chart indicate that the property of water through vapor through the following parameter. So we can measure dry bulb temperature, wet bulb temperature, also known as saturation temperature. We can call WBT in short form, dew point temperature in the short form DPT, relative humidity RH, moisture content also known as humidity ratio in this small W, enthalpy also known as the total heat in they will put in the small h in that psychometric chart, and specific volume, the inverse of density. So also we can check in the psychometric chart. So actually symmetric chart is to measure or to inform that condition is comfort or not comfort. So how to get that comfort? Should we follow the psychometric chart? One of the major application of the psychometric chart is an air conditioning, and we find that most humans feel comfortable when the temperature is between 22 degrees Celsius and 27 degrees Celsius. That in the temperature comfort, so that range from 22 until to 27, and the relative humidity, omega, between 40% until to 60%, yeah, for the relative humidity. This defines the comfort zone, which is the portrait on the psychrometric chart as shown below. With the aid of the chart, we either heat or cool, add moisture or dehumidify as required in order to bring the air into the comfort zone. Okay, this one is considered as comfort zone. Yeah. Okay, you can see the area comfort zone by given in the green color. Yeah. So mean, yeah, in temperature dry bulb, yeah, within 22 degrees Celsius until to 27. And then how about the humidity? Okay, this line with the curving in the blue line is shown as humidity, humidity percentage. So within 40% until to 60%. So from this area, so we can say, yeah, we can say this one enthalpy, yeah, within maybe less than 40, around 88, yeah, 88 kilojoule per kilogram until to 60, yeah, kilojoule per kilogram. We can say like this. So that one is a range for enthalpy in the comfort zone. And then we can measure this one is specific humidity in the gram. So mean in this one is gram. So within I think this one within 7 gram per gram until to this one 14 gram is content of specific humidity. That's how to see the psychrometric charts. Okay, any question? Okay.
No, sir.
Okay, I proceed to the next slide. Okay, what information? Actually, this slide is to inform us what parameter in one point can be inform us. Okay, let's say this point. This point will be inform us about relative humidity. Just find out the line, what line in the relative humidity in percentage. And then in the temperature, dry bulb here, in the x-axis, you can see in range temperature. And then what else? Dew point temperature mentioned in this line. Enthalpy in this line. And then humidity ratio. And then specific volume, this line. So how many line? 1, 2, 3, 4, 5, 6, 7. Around 7 information we can get from the psychrometric charts. All right. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Oh, this one is similar information. This one temperature. So that's why we come 8. Actually only 7. C and G is similar. Cooling to go down, heating to go up. So heating to go in the C, and then cooling to go to G. Then H, inform about the evaporative cooling only, and then D, chemical dehumidifying, so and so on. All right, air condition process in psychrometric chart. There are 8 processes in psychrometric chart for aircon. Okay, we have 8. sensible cooling, describing decreasing of dBT with constant W. Sensible heating, increase of dBT with constant W. That's how we achieve the human comfort using the psychometric chart. So we try to maintain a certain condition but increase a certain condition. So we try to get that one. So like sensible cooling, decreasing dBT with the constant W. So you can see which one W. So W is this one, F to B, F. And then we can see sensible heating, humidification, increasing W with the constant dBT, dehumidification, decreasing W with the constant dBT, cooling, humidification, decreasing dBT and increasing the of W, evaporative cooling. So this one we control in the econ system, how we control. So we can see this condition should be still in the human comfort area, in the green one area, just we seen before this slide here. Okay, what the meaning the dry bulb temperature is the commonly measure the temperature from the thermometer. It's called dry bulb since the sensing tip of the thermometer is dry. So see wet bulb temperature for comparison. Dry bulb temperature is located on the horizontal or x-axis. If the psychometric chart and line of the constant temperature are represented by vertical chart lines, since this temperature is so commonly used, it can be assumed that temperature are dry bulb temperature unless otherwise defined. Okay, actually dry bulb we measure with the thermometer just normal temperature, and then without any influence touching in the thermometer. No, mean the thermometer is clean from any anything, like the wet condition. Just measure directly to the air, and then we call this one dry bulb. And then how to see the dry bulb in the psychometric chart is on the x direction, x-axis direction. So we can get information the dry bulb from there in the psychometric chart. A relative humidity is a measure of the amount of water air can hold at a certain temperature. Is relative with respect to amount of water the air at the same temperature can hold at 100% humidity or saturation. At temperature dry bulb is important because warmer air can hold more moisture than cool air. At a 60% relative humidity contains 60% of the water it could possibly hold at the temperature. It could pick up 40% more water to reach saturation line of the constant relative humidity are represented by curved line running from the bottom left and sweeping up to the top right of the chart. The line for 100% relative humidity or saturation is the upper left boundary of the chart. Okay, totally relative humidity to measure the water content in the air. So once consider is 100%, mean the air already saturation. Saturation mean already fulfilled by water in the air. So mean we will feel very wet. Maybe like already perform in the smoke. You know, when already in the air already 100%, you can see like the smoke, SMOG, smoke. So like maybe the form is like a cloud, yeah, cloud. So we cloud. And then how to see in the uh, psychometric charts? Just follow the from the bottom, yeah, and then curving line running to the uh, to uptrend, yeah, to up, and then we maybe this one I already mentioned just now in the relativity line, yeah. Okay, wet bulb temperature is determined by when air is circulated past a wetted sensor tip. So it represents the temperature at which water evaporate and bring the air to saturation. Inherent in this definition is an assumption that no heat is lost or gained by the air. This is different from dew point temperature, where a decrease in the temperature or heat loss decreases the moisture holding capacity of the air, and hence water condense. Determination of wet bulb temperature on this psychometric chart follow line of the constant enthalpy, but values are read of the upper curve saturation temperature boundary. Okay, we go to the definition first. How to measure the wet bulb temperature? Just use the same thermometer, but we cover the tip by wetting cloth, yeah, and then we try to measure. And then that's mean uh, no thermal or heat loss from the condition from the air. So that's why I mean the wet bulb temperature. And then how to find the wet bulb temperature is just the left side from the psychometric chart. Yeah, so we can find the level, wet bulb temperature will be mentioned there on the left bar. The curve perform the look like the curving, yeah, curving. Follow the curving. Enthalpy is the heat energy content of moist air. It's expressed in British thermal unit per pound of dry air and represent the heat energy due to temperature and moisture in the air. Enthalpy is useful in air heating and cooling application. The enthalpy scale is located above the saturation upper boundary of the chart. Lines of the constant enthalpy run diagonally downward from left to right across the chart. Lines of constant enthalpy and constant wet bulb are the same on this chart, but values are read of separate scale. More accurate psychometric chart use slightly different line for wet bulb temperature and enthalpy. So actually, we when we measure the enthalpy in the psychometric chart, we can find they will meet a similar line within the wet bulb. Actually, in the real, it should be the separating the line within the wet bulb and the enthalpy. But the reading scale will be different. The enthalpy will shown outside, beyond on the wet bulb line. So on the left side. So this enthalpy is heat energy that contain in most air. So energy enthalpy needed to measure, yeah, because relate to the pressure, relate to the pressure condition of the certain area. So actually, when we develop or design the condition or zone, we should be measure, yeah, that the pressure should be not much different with the environment, because what if you measure the pressure is different, the enthalpy is lower or higher, so we will create the condition area will be vacuum or high pressure inside of the building. So this one will be influenced to condition. If the vacuum, they will absorb the air from the outside through the windows or the door. So will be bring together with the unwanted particle like the dust, anything like bacteria. This one is actually dangerous. It's unwanted in the hatchback design. And then how about the high pressure we create in the certain condition in the certain area? So what happen? If we create that one, so we will release the heat loss. We release to the temperature to outside the environment because we are high pressure. So we will get the efficient in the energy, because we will be release the air to the outside, from the maybe from the door, and or windows, anything. So it should be create the enthalpy also in the human comfort. So same like the outside or environment. Specific volume indicate that the space occupied by air is increased the density and is expressed as a volume per unit weight. Density is weight per unit volume. Warm air is less dense than cool air, which causes warmer air to rise. This phenomena is known as thermal buoyancy. By similar reasoning, warmer air has greater specific volume and is hence lighter than cool air. On the psychometric chart, line of constant specific volume are almost vertical line with the scale values written below the dry bulb temperature scale and above the upper boundary saturation temperature scale. On this chart, value range from 12.5 to until to 15 cubic feet per pound of dry air. Greater specific volume is associated with warmer temperature. Okay, specific volume is indicator to say amount of air is satisfied or not to serve the human. So the content of amount air should be a measure. If you need the oxygen, more oxygen, if the room is contain the certain number of people, you should be make sure the supplying oxygen inside or supplying the temperature inside is satisfied or not. So you should be measured by a specific volume. You need to supply the air, the amount of air inside of the zone. That's why we need to measure the specific volume, and the number is within 12.5 until to 15. So make sure this amount is enough. And then how to see in the psychometric chart? Yeah, this one is actually we can see a diagonal line, diagonal line to the left side, diagonal to left side. So you can see the value is same like dry bulb temperature, but different number mentioned in the x-axis in the psychometric chart. So you can find there the number of specific volume. Humidity ratio of moist air is the weight of the water contained in the air per unit of dry air. This is often expressed as pound of moisture per pound of the dry air. Since the humidity ratio of most air is not dependent on the temperature, its relative humidity is easy to use in the calculation. Humidity ratio is found on the vertical y-axis with line constant humidity ratio running horizontal across the chart. So we can see in the y-axis on the right side in the psychometric chart. So you can find dew point temperature indicate the temperature at which water will begin to condense out of the moist air. Given air at a certain dry bulb temperature and relative humidity, if the temperature is allowed to decrease, the air is no longer able to hold as much moisture. When air is cooler, the relative humidity increases until saturation is reached and condensation occurs. Condensation occurs on surface which at below the dew point temperature. Okay. Dew point temperature is determined by moving from a state point horizontal to a left a long line of constant humidity ratio until the upper curve saturation temperature boundary is reached. Okay, as we know, dew point is when saturation pressure meet in the saturation of temperature. Saturation pressure meet with the saturation pressure, so become condensation. So we should be avoid this condition. Yeah, we don't go to that below that temperature. So we try uh, to lowering the temperature to avoid when the saturation occur. So this temperature actually difficult to find out if I just explain without the psychometric chart. So actually this one is line is to left side, yeah, and meet to the wet bulb temperature. And then this line is come from the intersection humidity with the dry bulb. So we can follow to this line to the left side, and then we can measure this temperature actually from the psychometric charts. Never mind. I will give you an example how to carry out the information in the psychometric chart. Okay, this one, what I mentioned, we will go to analyze psychometric chart. Yeah. Okay, we have example one here. Assume that the outside air temperature is 32 degrees Celsius, mean dry bulb, yeah, with a relative humidity 60%. Use the psychometric chart to determine the specific humidity omega, the enthalpy H, the wet bulb temperature well bulb, TWB, the dew point TDP. Okay, from this example we can also find out the dew point. Maybe you can learn. And then the specific volume of the dry air V. Indicate all the values determined on the chart. Okay, let's check. Yeah, we have at least two information to make intersection line in the psychometric charts. Okay, we have two already here. 32 in the dry bulb, and we have a 60%. That enough to get 1 point intersection. Yeah, so 1 point there, and then we can carry out all information this one. Specific humidity, enthalpy, wet bulb, dew point, anything. Okay, let's check. Okay, now we have the two intersection here. Okay, let's check 32 here with the green line here, 32 dry bulb, and then we have 60% here, and then we have the intersection line. Now we just carry out what information. Okay, the first one, maybe here the enthalpy equal to 78, yeah, kilojoule per kilogram. What else? Up. Yes, this one is specific humidity in 18 gram moisture. And then what else? Diagonal. This one is specific volume. Yeah, maybe around. This one is 43. Yeah, 43 of. Sorry. This one is 0.60 meter cube per kilogram for specific volume. And then what else? This one, what I said, very difficult to find out TDP without psychometric chart. So you can see this intersection, we can go to left side until meet the, this one is a wet bulb temperature. And then just this point mention to the bottom, straight, vertical line to the bottom, and then this one we call TDP, temperature, dew point temperature, and then we can get around 23 degrees Celsius. So don't cross the 23 degrees Celsius to avoid the what we call saturation. Saturation need to pressure saturation. And then just put here the information, question, anything that asked in the question. Okay, any question in the example one? Ada soalan?
So far, okay, sir.
So far, okay. Okay, if you follow, still can understand the principle of psychometric chart, then we go to next example. Outside at the 35 degrees Celsius and 60% relative humidity. So now we have two parameters to make intersection in the psychometric chart. And then the other information to be conditioned by cooling and heating. Okay, we have three conditions here. The first initial, and then second point is first treatment, and then the last point 3 is last treatment. So we have initial, first condition, and last treatment condition. So what the wanted is to be conditioned by cooling and heating. Okay, provide cooling and heating. So bring the comfort zone using psychometric chart to plot the condition 1 minute. Okay, estimate A, the amount of moisture removed, the heat removed, and amount the added solution. Okay, remove mean differentiate within the initial to final condition. Then we differentiate, and then we can find the number differentiate that we consider as remove. And then B still remove, but in the heat. So mean differentiate in temperature, dry bulb. This one is dry bulb. And then C, amount of the heat added. Okay, this third condition after we cooling and then heated. So the first treatment we remove the moisturizer, and then we add the heat to increase the temperature, and then no more the moisturization. Okay, let's check the answering. Okay, we have two intersection here, 35 and 60 in first condition, that one. And point 1 already mentioned in the graph. After that, we remove the moisturization. So remove moisturization, and then moisturization become okay, this one is still in 60, become low temperature 25, become 2 point here, and then become 3. So now we remove until to around 50 something, around 50 something of moisturization, final moisturization. So now maybe around 10%, 10% is removed. Okay, let's check the answer. Process required to bring it comfort zone, cooling and heating. Okay, the first step, cooling process, decrease the T from the 35 become to the 25 here. Okay, and then decrease from 25 to 15 by 100% is relative humidity, and ratio decrease, enthalpy decrease, anything decrease, and become here. Okay, then increase temperature increase, come here from 2 to 3 constant W. Okay, as long we come into comfort zone, so the target is comfort zone. We come from here, temperature is not comfort, but humidity is comfort. What else? Enthalpy not comfort. So we reduce the enthalpy, we reduce the specific humidity ratio, we reduce what else? And then after that, we come to the comfort zone. So the target is area, the green area. Okay, that's how they treat. And then they calculate what differentiate. Differentiate. The first one, the amount of moisture removed, around 11.5 gram. And then B, the heat removed. So around 48 kilojoule. This one is per kilogram. This one is enthalpy. If you mention the temperature, mean the temperature also remove from 35 to the 25. So around 10 degrees Celsius. That's how we try to recondition the air condition to become comfort zone. Okay, now we go to example 3. Hot dry air at a 40 degrees Celsius and 10% relative humidity. So now we have two conditions to make intersection. Water is added as air passes through a series of wick, and the mixture exits at 27 degrees Celsius. Using the psychometric chart, determine A, the outlet relative humidity, the amount of the water added, the lowest temperature, the equilibrium. That's the solution. Okay, we should be understand the situation first. Okay, let's check the figure. The figure is actually the humidity is lower. Then we try to add the humidity by put the wick, yeah, mean the wet wick, yeah, because influenced by water here. So we add the wet wick here, and then we can increase the humidity. Okay, let's check the graph. Okay, first condition 40%, mana dia? This one. And relative humidity 10%, humidity pass through the evaporative. Oh, the one is 40%, 40 degree with the 10%. Okay, 40 degree. This one. And then 10, come here. And then still far away from the comfort zone. Then we can reduce the temperature and adding the humidity. Okay, become to this one 10. Okay, this one 10%, sorry, 10% with the 40, this one. And then we go to the comfort zone. Okay, so reduce in within the 22 around with the 27. We can choose anyone within this area, and then we can reduce the temperature and add the humidity. Process required to bring air to comfort zone, increase humidity, add water, no heating and cooling process. So in the psychometric chart, increase the humidity without increasing the enthalpy. And then we can get the answer 45% relative humidity. We can choose 40, and then 10%. Here the ratio. Sorry, not percent. 10 specific humidity ratio, and then in this one is still maintain of the specific volume, maintain in 0.9 around 10, 10. I think the 10, 1 specific volume meter cube around here. So maintain, and then the enthalpy also maintain. Enthalpy also maintain. Yeah. So the comfort zone, and then the lowest temperature that could be realized can be 18.5. Boleh pergi dia sampai negatif ni kalau nak. Kalau maintain ni, maintain can go until to 18.5 degree in dry bulb for meet the dew point. Di sini akan tak boleh rendah pada ini, nanti akan jumpa saturation, nanti akan jadi pengembunan. Okay, then we go to example 4. I think this one is the last example. Assume that the outside air temperature is 8 degrees Celsius if the air in a room is 25 degree with a relative humidity or omega 40%. Use the psychometric chart. Okay, let's go fast. And then okay, first condition is 8, and then in a room is a 20 degree, relative humidity is a 40. So we go to the 25 degree with the 40% of the RH. So target should be become here. And then the air contact with the window will become colder, and then dew point is reached. Notice that what you find if you go to this one. So akan ada fogging fogging apa semua. So pengembunan lah akan jadi pengembunan. Sebab dew point akan jumpa. Di bawah dew point mengembun lah. Ya. Okay. Okay, that's all today. Any question? Ada tak nak ditanya?
Tak ada, sir.
Kalau tak ada, saya take attendance lah ya. Where is our attendance? Attendance. Chu ada tadi ya.
Ada, sir.
Kartik ada tadi ya.
Ada, sir.
Tanvir tak ada tadi. Tanvir, are you there? Muhammad Irfan Rawati ya. Tadi ada ya. Muhammad Izmul Faris.
Ada, sir.
Muhammad Izzat bin Saleh.
Yes, sir.
Muhammad Umarul Adin.
Ada.
Muhammad Sazwan Zulhilmi.
Ada, sir.
Muhammad Adib bin Muhammad Nur Adenan.
Saya, sir.
Muhammad Adib Hakimi.
Yes, sir.
Muhammad Aiman Haikal.
Ya, saya.
Muhammad Akmal bin Muhammad Nur.
Saya, sir.
Muhammad Amir Syafiq.
Ada, sir.
Haris bin Johari.
Ada, sir.
Muhammad Hazim bin Ahmad Zulkafli.
Saya, sir. Ada, sir.
Muhammad Hazim bin Mansur.
Yes, sir.
Muhammad Izzuddin bin Mukhtar.
Saya, sir.
Muhammad Mustaqim.
Ada, sir.
Muhammad Syahir. Muhammad Sufian.
Ada, sir. Ada.
Muhammad Syahir bin Ma'ruf.
Ada.
Muhammad Syahmi ada. Nabil Aiman.
Ada, sir.
Noraiman Naim.
Ada, sir.
Parani.
Ada, sir.
Umarul Hakimi.
Saya.
Wan Ahmad.
Saya, sir.
Alright. Ada nama yang tak panggil lah? Tak ada eh? Okay, that's all for today. We try to continue. We postpone until to next week. And then we continue to next topic. Then don't forget to check your ULearn, your assignment with your group ya. Thank you. Assalamualaikum and good afternoon.
Salam.
Sir.
Thank you, sir.